Hi everybody, I'm Yi Jun Wang. Today we're going to talk about converting regular expressions to NFA and DFA. If you are a computer, you need something more systematic. For example, an algorithm to follow. So what does that mean? That you have to set a specific set of rules in a very specific set of steps to follow. If you want to convert a regular expressions to NFA, you need two steps. First, you need to convert the regular expressions to NFA, and then AFA to DFA. We will be using these examples through this whole video. It does not matter that you do not understand this symbol right now because we will be taught that later on in this video. Let's start our first steps, converting the regular expressions to NFA. Before we start this process, here's some rules that you need to remember before we convert the regular expressions to the NFA. The first one is A or B. It is represented by two states. So this is two states, and this is followed by two transactions go between these two states. One is A, and the second is B. And second one is A or B, done by three states, followed by two stages between them. The first one labeled A, and the second one labeled B. The third one is the final one, A star, done with four stages, and A is go in the middle of the two, and absent between the others. So, anyone will ask me what the absent means. So absent means zero or more. So the problem that we're going to solve is A star followed by C followed by B star. So, under the first step, we have several more steps to follow. The first one is to separate the regular expressions into the small parts. So now to solve this, you first need to recognize this is not A star followed by B star. You cannot think about that at A star followed by C followed by B star. We need to simplify this one. Now to solve this, first think about D as B star. And then we can have consider C followed by D as the whole part. Let's make it N. And also we make N equals A star. So here's comes our final outcome. The simplified final outcome is N followed by N. And here comes our second part, step, converting to diagram. Since we already put off the difficult expressions inside one symbol, we do not need to worry about it right now. We can just first start drawing the N followed by M diagram. We will then consider the difficult part inside the symbol. Let's start applying rule for the N followed by M diagram. Here's what the diagram looks like. Here's what A star looks like. Then we start breaking the M part. M part, which is C followed by A, followed by D. Here's what it looks like. And then we start the D, which is B star. Here's what the B star looks like. And there's a solution for the A star followed by C followed by B star. We make this one as this one. You have to consider like this two circle, this is our acceptance state. We make this one because B star means 0 or more B characters. We know this is a diagram that non-determinate because of this absent transactions. Now here's kind of fun part. How to convert a long-determinate state to determinate one by getting rid of these absent transactions. Before we begin, let a good start writing some strings that are accepted and not accepted by this NFA. So the first step, under the second step, is by converting a yes or no table. Because of the time limit of the video, I'm just showing you a few examples under the yes. You can pause my video and do the rest of this under the yes column and no column by yourself, and then come back to the video to check your answer. So, for example, this is our diagram. We can do state 2 with followed by A transaction, and then we'll go all the way to the state transaction, go all the way, we go to our acceptance state, which is 8. And then we can also do A followed by C, and we pass by the acceptance state, and we followed by B, and then we go all the way around to the acceptance state. So A say B is okay. And under the no column, we cannot do A, only do A transaction because there's no way we can go to the acceptance. unless we go to the C state, right? So A is not okay. And then you can do the rest of this by yourself to check this diagram. Okay, here's the rest of them will work. The second step is create a small chart. This is basically take all the information out of the AFA and write it out in the grid format. The same with the yes or no column. It is the same with this one, but it's just kind of like a good format. I will just present what different parts compose this chart and show you a couple of examples. You can convert this by yourself. If you need to, you can pause this video. On the left side of this video is our state number. And across the top, we put all the possible inputs. I'm going to talk about this epsilon columns more in detail. Recall from the last slide, epsilon means that we create 0 or more. What that means? It means that if we are in a particular state, we can follow 0 or more transactions. And where do we end up? We could go to the state ourselves because that means 0 epsilon. We can also go to the state followed by 1 epsilon. So for state 1, because there is no, just check this diagram, because no epsilon go inside of the state 1. So for state 1, there's always sort of impact 0, so we can stay where we are. For example, if we're state 1, then we can do 2 or 4. Just check this one. We can go 2 or we can go 4 states under the epsilon, right? Under the epsilon state. But under the state 2, so first off, under the state 2, you can check out under the epsilon, we have the epsilon to come out inside of the state 2. That means we have 0 epsilon, we can do it by ourselves. Okay, and you can do the rest of this by yourself. It's not that difficult. And the first structure here, and we can create another chart. What is epsilon star means? If I have state 1 and follow A followed by 0 or more, we need to figure out what we end up. So if we want to complete this table, this one table, we need to use this first table. And we can find out what we are end up in state. Then we start. So first, we start with state 2. We found out if we go A first, let's see, we go A first, we end up this 3 state, right? We go to the 3 state. And then we check out the 3 state. If we go 3 states and epsilon state, we end up to 3, 4. So now we create just and add 1 new entry here. So we will continue with this 1 new entry. So 3, 4 means we are in either 3 state or state 4. So the 5, 8 is the accepting entry because so we start with 3 or 4, we end up at 5, right? And then we start with 5, we end up 5, 8. That is come to our another new entry. We start with this 5, 8 state. So the 5, 8 is accepting entry because it involved 8. So 8 is our accepting state. So if you get to the state 5, 8, you just loop there every time you get a B connection without having to go to the 6 or 7. I know everyone's just like checking out 5 or 8, we go to 6. The 6 there, we end up to 6, 7. That doesn't make sense. It just make a mistake. Because 5, 8 is our accepting, we just like stay in the accepting state, and we're just using the B transactions by itself to go to the state by itself. Now, here's come to our third part. We use this table and we convert this diagram, this real DFA diagram. We do not need the 1 state and 1 state that say this table because 1 state there's no entries here. So that means it does not meaningful that we put 1 state here. There's no other state that come back to this 1 state. And here is our diagram look like. It's very simple. You just follow this table and you draw all the state and you follow these transactions and you create this diagram. So, okay, everybody, here's kind of our whole part of the art that how you can convert a regular expression into DFA. So always remember, you start by it into the NFA first and then into the DFA. This is not a hard concept, but it just takes some time to do the process by hand. I try to make the difficult part into small and easy part to follow along. I hope you can join this video and understand the concept. And thank you.